if you want to name this, first identify the fatty acid is present. This one is what? Since we have 3 palmitic acid, you name this what? Tri-palmitin. Triacylglycerol. Look at the name, oh. Look at the name very well. Glycerol. So this should tell you that the alcohol present is what? Then tri means how many? 3 acyl group. The acyl group is coming from the fatty acid. So we are going to be looking at triacylglycerol. It is either you call it triacylglycerol or you call it triglyceride. Triglyceride. Now, if you are following our previous lessons, what we've done in this topic already, you should note that triacylglycerol falls under simple lipids, right? And simple lipid is composed of what and what? Good. And if the alcohol present is glycerol, let's look at that state. Triacylglycerol. Look at the name, oh. Look at the name very well. Glycerol. So this should tell you that the alcohol present is what? Glycerol. Then tri means how many? 3 acyl group. The acyl group is coming from the fatty acid. So this should tell you that we have 3 fatty acid esterified to what? Glycerol, right? Now let's look at the structure of glycerol. Glycerol has 3 carbon. So this is our glycerol, and all the 3 carbons have OH. Then after that, you just complete your carbon. Carbon is supposed to be tetravalent, right? 4. So you complete your... This is the structure of your glycerol. Now, if we have fatty acid, remember that fatty acid is represented as ROCOOH, right? Is it not? These are fatty acid. Listen, I'll give you time to draw, but just understand. These are fatty acid. If I change it like this, if I do like this, have I changed anything? No. This is still COOH, right? Yes. What if I do it like this? Have I changed anything? No. I just flipped it, right? Because the reaction will be between this. So I'm just going to take this now, this fatty acid now, and put it here. Please listen up. Let me use arrow 1. Now, this is our fatty acid, right? This is glycerol. If there is a condensation reaction between this, and in condensation reaction, water is given off. Water is what? H2O, right? Or HOH. HOH will still give us H2O, is it not? So, if these two things are coming together at this point, H will be taking OH, right? So, water will be given off. So, if H takes OH, water is given off, and that one is out, right? We'll now join this. Do you get? So if I bring this close, I'll be having, right? Now, the one fatty acid have been attached to glycerol, right? Now, this is one acyl group, is it not? One fatty acid group. So this will be what? Monoacyl glycerol. Do you understand? So this is, I'll take it again. Now, alone, we have, if I put H here, this is glycerol, right? Now, this is the structure, the general structure of our fatty acid. If you are bringing the two of them together, condensation reaction will take place. And in condensation reaction, we are giving out water, right? Now, water is HOH or H2O. So this stuff here is going out. So if I clean this stuff out here, if water is going out, it means I'll just connect the bond here, right? And H2O has been given out at this point. Do you get? Now, this is an acyl group. Just one acyl group, right? So you call it what? Monoacyl glycerol. Now, if another fatty acid comes here, and water is still giving off to form this, and water is giving off. This is called what? Diacylglycerol. This is diacylglycerol. You already know the structure of triacylglycerol, right? Good. Because if another one comes in here and water goes out again, what we will now be having is what? Triacylglycerol. Water is going out. So we now have the structure of what? Triacylglycerol. TAG. So you see that triacylglycerol, we are just having glycerol molecule with 3 fatty acids, right? 3 fatty acid molecule, triacylglycerol. Don't draw it. Now, remember we are just using, is this in palmitic acid or stearic acid or what? You don't know, right? Because we are not showing the alkyl chain. Now, depending on the alkyl chain present, when we use the real fatty acid now, not the general formula, then you see that triacylglycerol can be classified into 2. We will have simple triacylglycerol and the mixed triacylglycerol. Just get the general overview. Now we'll take them one after the other. But just get the general overview. We can have simple or mixed. Now if we have something like this, look at it attentively. I'll see who is thinking very fast now. I'll see who is thinking very fast now. Which fatty acid did I attach now? Fast thinkers. Which fatty acid? How many carbon? They don't the open book. This 1, 2, this 14, right? 15, 16. And it's saturated, so it's what? Palmitic acid, right? Good. If I attach another palmitic acid here, and I attach another palmitic acid here, all the fatty acids are palmitic acid, right? Is it not? Now, in your own opinion, is this a simple fatty acid or a mixed? Sorry, is it a mixed triacylglycerol or a simple triacylglycerol? So we've seen that depending on the type of fatty acids found in the triacylglycerol, triacylglycerols can be classified into simple triacylglycerol and what? Mixed triacylglycerol. So the first one, the simple triacylglycerol, all the 3 fatty acids present are what? Are the same. The 3 fatty acids present are the same. So take for example, if you have something like this, this is the structure of what? Glycerol, right? Now if I esterify it, remember I've taught you how to esterify. Which fatty acid is this? 14, 15, 16. Palmitic acid, right? Which one is this? Palmitic, right? Which one is this? Still palmitic acid, right? Now, if you notice the 3 fatty acids attached to this glycerol, they are the same. Palmitic acid, palmitic acid, palmitic acid. So we said this is what? Simple triacylglycerol. For example, this is named as what? Since we have 3 palmitic acid, you name this what? Tripalmitin. Tripalmitin. If we have another one, if we have another one, if I esterify this with Now, you notice that the fatty acids present here are also the same, right? Which fatty acid is this? 16, 17, 18. So which fatty acid is this? Stearic acid, right? This is also stearic acid. This is also stearic acid. So this is a mixed, this is a simple triacylglycerol, right? Because all the fatty acids present are the same. So how will you name this? Try what? Try styrene. Tristerine. Remember we said stearic acid now. This one, palmitic acid, we just remove the C and put N, palmitin instead of palmitic. Yes, stearic instead of the C, we put N. So tristerine. So these are examples of simple triacylglycerol. Now you're going to do a classwork for me now. Draw another simple triacylglycerol using another fatty acid apart from palmitic acid and stearic acid. So draw simple triacylglycerol for me. Everybody draw. Those of you following online, draw, and the days to snap and drop in comment section. All right, so please draw. All right, so please look up. Mixed triacylglycerol. In the mixed triacylglycerol, the three fatty acids are not the same. The three fatty acids are not the same. Remember that in the simple triacylglycerol, the three fatty acids are the same, right? Now, in the mixed, the three fatty acids are not the same. Can have two different fatty acids or three different fatty acids attached. So let's look at an example. This is the structure of our what? Glycerol, right? Good. Now, one thing you need to note, when you are drawing your mixed fatty acid, your mixed triacylglycerol, carbon 1, what you always have there is a saturated fatty acid. So the fatty acid you're putting here should always be saturated. No double bond should be found there. Do you get there? But other ones you can put either saturated or unsaturated fatty acid. Now here, if I put something like this, all right, now look at this. This first one, which fat, if you want to name this, first identify the fatty acids present. This one is what? This one is what? How many carbon? 14, 15, 16, right? Palmitic acid, right? This one, how many carbon? 7, 8, 9, 10. 10 plus 17, 18. And it has one double bond on 7, 8, 9. On carbon 9. So 18 carbon, one double bond at carbon 9. That is what? Oleic acid, right? Oleic acid. And this is what? This is what? 18 carbon. So it's what? Stearic acid, right? Now you already know that this one is palmitic. This one is oleic. This one is stearic. You take note of the position. This one is on position 1. This one is on position 2. This one is on position 3, right? Position 2, position 3. Good. Now, just like your IPAC nomenclature, you name it alphabetically. You name it alphabetically. So which one should we start with here? Oleic, right? Because O comes before P and S alphabetically, right? Now, when you are naming it as a substituent, just like methane, if it's as a substituent, methyl, right? Is it not? Ethyl and all these things. So you don't use oleic. There are two ways you can do that. You can say oleio or oleiol. But the oleic acid is on carbon what? So 2 oleio. Which one should we go next? 1 palmitoyl 1 palmitoyl what? 3 what? Now styrene is this one is the main, is the last one, right? So you're not taking it as a substituent again. You state the full name. So 3 what? Styrene. Now take note that if you see it this way, oleo no YL, palmito no YL is still correct. So you can still go with 2 oleo, 1 palmito, 3 styrene. It's still correct. Good. Just like it's just same thing as when we have methane and we are now using it as a substituent. You have methyl YL. You see the YL we are adding. Now look at this. Let me take it again. This is a mixed triacylglycerol. You want to name it. The very first thing you have to do is identify the fatty acids present. This one, this 14, 15, 16. 16 carbon, no double bond, we know it's palmitic acid, right? This one, if you count the total number of carbon, this is 1, 7 plus 1. Please don't count this one. This one is for the glycerol. So this 8, 9, 10. 10 plus 7, 17, 18, right? 18 carbon with 1 double bond, right? And the 1 double bond is on carbon what? 1, 8, 9, right? It's on carbon 9. So here we have 18, 1 double bond on carbon 9. If you check very well, this is oleic acid. Oleic acid. Now this one, 16, 17, 18. This 18 carbon, right? With no double bond. 18 carbon, no double bond. 18, no double bond. So this is stearic acid. Now you have to name it alphabetically. So you take the list according to the alphabet. O is the list here, right? So oleic acid, but here you don't write oleic. This on carbon 2, right? This carbon 1, carbon 2, carbon 3. Carbon 1, carbon 2, carbon 3. So 2 oleol. You just add your YL, just like methane, methyl, YL, ethyl, all those things, to show that it's a substituent. Then the next one after O is P, right? So, and it's on carbon 1. So 1 palmitoyl, then 3 styrene. Remember, we're always ending the name with ring in. So instead of 3 steric, 3 styrene. So this is the name. And it's a mixed fatty acid, mixed triacylglycerol, because we have different fatty acids attached. Yes. You just indicate their positions. So if the styrene was at position 1, you still name it the same way, but here you now have 1 styrene. You say? No. Now listen. We are not putting 3 styrene because we are not using this because this is the last. Alphabetically, S is the last. So that's why we are bringing styrene to the end. So anyone that comes to the end, that is the one we use as the parent. Not because it's on position 3, but because S is the last in the alphabet. O, P, Q, R, S. That's why this is here. Yes. Alright, so I want to adjust this now, then we see the name. What if we have something like this? What if we have something like this? Now check. This one, what fatty acid do we have here? This is palmitic, right? Which one do we have here? Oleic, right? Which one do we have here? Palmitic, right? Good. This palmitic. Now, if you are naming this, O still comes before P, right? So, and O is on position what? So, 2 oleol, 1 what? 1, 3 what? Dipalmithene. Do you understand? 1, 3 dipalmithene. Because carbon 1 and 3, they are the same thing, palmithene. So that's what. Now you name this one for me. But draw that, then name this one for me. So as classwork, draw the structure of, this is classwork, draw the structure of 2-permethyl 1,3-disterene. So 2-permethyl 1,3-disterene. Draw that for me if you're done. Let me know.